All right, let's get started here with Unit 8 of our Linux Security Engineering course for the Professional Linux Users Group. My name is Scott Champagne. I've been running the course and getting you guys all ready, and this is just going to be a recording of the Unit 8 material that we did from yesterday. All right, so announcements. We're in our 8th class meeting. We've got an event coming up in August that's free. Everybody can go hang out down in the Discord. We've had a few hundred people come to those last year, and I'm hoping to get in the many hundreds this year, and I hope we just crush Discord. That's always the goal, is to crush Discord when we do this. But sign up, attendance is free. You can invite people. You do all that kind of good stuff. All right. Last week, what did we do? Well, last week was recorded a few hours ago, but for the purposes of the course, it'll be last week. And we talked about what did we monitor and how do we decide on what to send out of the system as an alert. Like the system's going to call for help, and when is it going to do that? When does that happen? And that's kind of a critical thing, and I have you go and explore that a little bit in some of the course. We actually worked on building the monitors out and sending the alerts, but there's so much theory behind. I always tell you guys that there's a difference between art and engineering. If it's engineering, I can give you the 10 steps to do something. It's step 1 is get out of bed, step 2 is make your bed, 10 steps, boom. You have engineered the beginning of a good day or whatever. But if it's art, it's like, well, you do a little of this and you dash a little of that, and it's like grandma's cooking. Like it's a little of this and a little of that, and then it's pretty good when we're all done with it, right? So there's an art to alerting, but there's also some elements of rigor that should be applied as well. So anyway, so how do we decide on what to alert? There's a lot of different places that you go and look at. We have a worksheet for last week. We have a lab for last week. Hopefully it's good. We just recorded it. This, then the last week review is what are we monitoring? The 3 big ones are telemetry, trace, and logging. Those are across all the systems. How do we monitor? We take either an agent or some kind of tooling, and we send up one of those 3 things into an aggregation point of some type. The aggregation point tends to be some kind of what we call a time series database because it's optimized on time, right? Then we talked about what is alerting and how we send those messages outside of the system to Slack, to Discord, to Pager Alert, or Pager Duty is one of them, rather. You can send all these things, and what we did was we built a Grafana dashboard alert into Discord, so that triggered while we were on stream earlier. And then how do we alert? We have to have a priority to things. Not everything's always important, and the windows of time also dictate what's important. I was talking about, like, if it's 9 a.m. on a Monday and I'm in the office, back in the day, or even when I'm sitting around at home in the office working on a system, yeah, you can trigger me all kinds of development alerts, because if development environments are down, then my users, which are the devs, are down. I don't want that. I don't want the users to be down. So that window of time would be good. But at 6 o'clock on like a Sunday morning when nobody's working, that's not a window. Unless people work all over the world nowadays. There's global workforces. Sometimes the windows are like that. And then we talked about whether or not it's tenable for you to continue doing that or not, right? So that's last week's review. This week, oh, you know what? I meant to update these. Anyways, we'll talk about what the topics are. I didn't update the topics apparently. And then we do a worksheet and a lab monitoring. So let's talk about what this week's about. There's a life cycle to systems management. The whole thing that we've been doing in this course has been building and securing Linux systems. That's the whole idea of this course. So what is the life cycle of that system? How do we build and apply configuration management? Now, we've been configuring the system the whole time. Some of you are probably like, Scott, we've been doing STIGs and we've been doing all these things. And I say, yes, that's true. But when we build the system, we set a build, typically we build a build book with it. And this is exactly how the system was built. And then as the system runs, we update the run book as this is how the system runs, this is how we do things in the system. It's almost like your owner's manual of that vehicle. And what we're trying to do is avoid losing. Configuration drift is going to happen. Let me step back for a second. Configuration drift will happen in Linux systems, in all systems. From the time I turned on this laptop, it started drifting configurations. From the time you put a fridge in place, the fridge is starting to change. Like, things are happening and changing, right? And slowly they're going to break. What we don't want is to miss configuration drift. There's 2 types of configuration drift. There's unauthorized ones, that's bad, and there's the ones that happen just over the entropy of time, right? The normal system operation. So configuration drift is bad, but we can also track things that are changing so that it's not as bad. So anyways, how do we can deal with the configuration drift? There's operational practices. We set up a change management team. We have a CMDB, which is change management database. We put in there configuration items, and configuration items are things that we agree need to be configured and tracked. And then there's technical practices. So we can do things technically as systems engineers and systems administrators to watch things change. There are playbooks we can run. We can write our own little scripts. We can do hashing functions to make sure that files are the same in two locations. You could have rsync backing things up, and then every time it backs things up, it goes and it just checks a hash to make sure they're the same. That is a technical practice that verifies there's no configuration drift between those two systems or whatever you're doing, right? There are other things technically that we can do. We could have two systems tied into the same back end. We can have highly available systems where only one is active and the other is passive, and then they read from the same database. There's all kinds of things we can do technically, right? Then there's system built-in tools. There's tools like AID, the Advanced Intrusion Detection Environment. And AID is kind of like, we used to have a tool called Tripwire back in the day, but Tripwire I don't think it's been maintained for the last like 12 or 13 years or something. But AID is this advanced intrusion detection environment that just goes out and it just kind of throws these tripwires everywhere. In that, it hashes and keeps track of all the major system files that you want to track. So we're going to install that on the system, and we're going to look at, hey, what are all the I think when we did it yesterday, we saw it's like 119,000 things it's tracking. You change SE Linux labels. You change advanced access control lists on a file, not just your base ACLs. You go to your extended access control list. It's going to do that. So it's going to track all those changes, right? And then we have like kind of custom automation, which is kind of the technical practices but put into an automation sense. Now, step back for a second here and just talk Linux. When you're at a command line in Linux, when you're at the command line in any system, there's only two things you ever do. And I've told you guys this before, and I don't challenge you, but I say prove me wrong if you want. There's only two things you ever do. You set values and you check values. It's the only thing you ever do at a command line. You input to the system, you're either checking a value or you're setting a value of something. And that could include kicking off a program and making a change that's setting something, right? But my point is, in automation, it's the same way. We can check things and we can fix things. Now, checking things is almost like you're just watching a race happen. You know, there's a two-lane race, NASCAR, and they're just going in circles, turning left the whole time, right? They're just going like this. But checking drift could be we just watch them. We just track them, track how much things have changed, how much they've drifted off of maybe like a center line or something like that. But we don't change anything. We just watch. It's like an intrusion detection system. Fixing drift, however, is always catastrophic. It is always a change to something in the system. It would be like if I was like, hey, I don't want those guys in that far lane. I want them all on the inside lane the whole time. They can't drift out. So I just drop like a cinder block in front of them. Like I have one of those little crane things that'll drop the, those concrete pylons. And if that goes in front of something that's running a running process or a car or something, that'll jack the whole thing up, won't it? So fixing drift is almost always what we call disruptive or catastrophic in the system, in that if people are changing things outside of our normal change practices and we are dramatically setting them back, which we can do with Ansible, we can dramatically set things back. We will break the old thing, but we need to understand that, right? We need to understand what do we want to do. And a lot of times we turn things on in check mode. By the way, this is exactly how SE Linux works. SE Linux has permissive mode where it's just watching and telling you. And then when you go into enforcing mode, it locks everything down, right? Those are the same types of things happen where we check or we fix things. All right. So configuration management kind of looks like this. You have system build. Engineers build systems. You know, we go over there, we plan and we design and we do our stigs and we get everything built. And when we're done, there's two things that are going to happen. We're going to hand those systems. I was talking about like pushing my server off into the night like it's a ship. And I don't know if you guys saw that ship in New York that crashed last night or whatever. Like the Mexico Navy was like bringing the ship and it crashed into the Brooklyn Bridge. Like I don't know how you don't know exactly how high off the water the Brooklyn Bridge is, but they crashed into it twice. Each of its masts crashed. But anyways, where I'm going with that is we push our servers off into the night, right? And as soon as they go out there, things start to change on them. Admins make changes to fix systems. Something breaks, something fills up. They got to delete stuff. They got to change the way that log rotate works. Right? Like I built the system and log rotates either out of the box or something that I manually set to maybe make some stig correct. but then they find that that doesn't work operationally and they have to change it. So things immediately start changing in our system. User requests come in. A user immediately on their dev team needs some service account to have certain sudo permissions. I didn't set those sudo permissions up on that box. That's a change. That is not part of my original baseline. That's not part of my build book. It's part of my runtime or my run book that's originally created, but then the run book has to be updated as these people are making these changes. So that's what this diagram is showing here. Operational teams also are going to make changes for security fixes, and then those changes have to be built back into the base image of the system. In fact, there's labs that we're not going to do today that deal with that, about updating the security baseline. There's older labs that I have from the Killer Coda labs for that. But then over here, the function is we should be able to take any build book and rebuild the system from scratch. In fact, our goal, our automation goal as engineers, as system build engineers, right? If I'm building Linux platforms for people, I want to be able to push a button and redeploy one of my systems. I can only do that if changes that are applied here are making it back up into my pipeline and being tested, so that when I hit the button, I'm not deploying a server from 3 years ago. I'm deploying a server from X amount of years ago with all of the current baselines and everything applied to it, and now it's set up. So we're going to talk about that here in a little bit, and you guys are going to get to see some of that in the labs and stuff, right? But operational teams, again, admin teams, and you might say, hold on, Scott, like I've never worked somewhere where the engineering team is different than the admin team. It's the people. Yeah, well, so you're wearing two hats. You're an engineer when you build stuff and plan and do projects, and you're an admin when you're doing operational activities of keeping things working. That's where I'm drawing that line there, in case anybody's wondering. And then here's our little functions of those things. All right, so this is all good. Like I like showing you guys theoretical stuff, and I think theoretical stuff is valuable because it gives you terminology and stuff to go read about and that kind of stuff later. But a lot of times we have to just like touch this stuff and get our hands on it. So let's go down a little more. Some more things that I already mentioned, but we'll talk about again. Key concepts. You've got configuration items. They're hardware, software, documentation, or components that need to be managed. So your server, RHEL 8, it's a RHEL 8 server or RHEL 9.5 version of, a major and minor version. It is hardware. Boom. Or it may have underlying hardware on it. It's technically software, as are all of its packages. And you might say, wait a minute, you mean I got to track all 400 something? Yeah, you have an original baseline of all packages on your system. There's a lot to do. Super easy to pull, super easy to learn how to pull that and turn it into a little CSV and feed it over to your security team, then go put it up in Archer. All the software versions are going to be there, though. So now, as we patch or as our versions of software fall out into, different CVEs are found for them with certain CVSS scores, we're going to have to patch things and then keep track of how they were updated over time. And this is a thing that it's very difficult to do. That's why it's good to have a configuration management database, a CMDB, to track this. So you've got your software. Again, your operating system is technically a software. Documentation. How it was built, what automations were involved, what platforms were built, what environments has it been tested in. Those kind of things all need to be tracked. And then a baseline is the set of configuration items that have been formally agreed on to serve as a basis for any future changes. So this is our base platform, and then things are going to change, and then we're going to roll things back to that if we need to. Change control, again, a lot of times engineers, we do not like change control, right? We just want to be down there testing things and building quickly. But when we're ready to deploy things, we need to make sure that we have them approved with what we call RFCs, typically requests for change, and then those go through like a change advisory board or some call them electronic change boards, where you just meet up and or engineering change boards. People have all kinds of different names for them, right? And then you have something that's doing your configuration status, which is typically a CMDB, configuration management database. A lot of you guys are probably familiar with ServiceNow. That's a CMDB. Some people use a tool called SolarWinds is a very good IPAM, right? It does IP address management. But you can also do with SolarWinds a bunch of configuration management stuff if you want as well. So I've seen people use that as kind of like, I don't want to say a poor man's because you're paying for SolarWinds, but it's like a cheaper CMDB than going all the way to ServiceNow. But ServiceNow is one of the big ones. Another one that's kind of big is Sharewell. You can use Sharewell as well. And then configuration audit. You got to track these things. And Raleigh just mentioned if your CMDB isn't complete or isn't updated or you rely on it, you're screwed. I have never worked anywhere in my career where a CMDB was always up to date like I think it should be. Now, that being said, every time that I've been given access to an API and I've been able to do APIs from my team, my stuff is always updated. I keep my stuff updated with the CMDB. I sync that religiously. I use Ansible Automation Platform and Ansible. We're going to do a little bit of Ansible stuff, but not necessarily to something like Sharewell or that. But this is a really good way to start to get the ideas that are going to come. And the security course is about being a security engineer and interfacing with the business. So this is something that's very valuable if you're going to be building systems and keeping them on a security baseline. All right, so goals of configuration management. We want consistency. When somebody pushes a button to get a server and it rolls down the little ramp like a little gumball coming out of the gumball machine, if they push that 3 times, it better be the same damn server all 3 times. Don't want it to just be one-off. Efficiency, this is the other one. I'm mostly dealing with consistency and efficiency. The other one is they don't want to push the button 3 times and then wait 3 weeks for somebody to build 3 different servers that are inconsistent. Nope. We want to have it as a pipeline. When they push the button, it should build the server, it should come down. Now, traceability is also valuable. Track changes to the CI, so maybe we automatically send some stuff up to ServiceNow. Maybe we automatically, one thing that we always do on the Red Hat side, if you're heavily into Red Hat, we always register back with Satellite. Which, by the way, one of my favorite things to do is to pull everything out every morning for my inventories, comes out of Satellite every morning. And you say, well, why is that? Well, because Satellite's where the money's spent, so Satellite is always the most accurate thing inside of your company if you're doing Red Hat side of things. I imagine there's something on the Windows side. I'm sure Active Directory has some kind of function where they keep track of everything, or maybe like your WSUS if everything's going to like a WSUS server. Because look, that has controls in place to make sure that you're paying for everything, right? That's how Satellite works, right? SCCM on that side. Yeah, that's fair. Yeah, SCCM. Yep. I had friends that used to run that, and I'd help them with the API stuff, but I'd stay out of it otherwise. Then accountability. Yeah, define who's responsible for changes. So who is the one pushing all those buttons? And a lot of times inside of accountability, we also have not cost control, but some people would call it chargeback. So your team can only push that button so many times. Your dev team has 20 or 30 servers that they could have at any given time, and they can push those buttons and deploy them, and maybe they have a typical shelf life of like 1 month to maybe 3 months. That's typically what I build my dev type when in our kind of ephemeral dev space, not like our hard dev space where people have to go through change. We typically have like, it's almost like a little sandbox. I like to think of them as sandboxes because they can just go push, get 3 servers. They can define them as a web, an app, and a database, and then they can just go right in and do all the stuff without ever having to interact with me or anybody else. And that's really, at the end of the day, what I want. I don't want anybody to have to ever ask me a question. And the type of company that is, if you guys have ever heard of this or if you want to learn more about it, is go look at API-driven companies. The goal is if somebody has to come and ask Scott, the engineer, I'm typically the lead, but Scott, the engineer, instead of having to ask me, I just present an API and they can just call it, right? And they can check whatever it is. And that's one of the reasons that a centralized CMDB is so good. I can keep that updated and you never have to ask me anything. I just have to teach you how to make the calls. All right. So down here, we're talking technically for a change. You've got some kind of file. And in this case, we want to check the way that we can kind of weigh the file to make sure that the file's the same. So we're over here and we are tracking something before a move, and then we check it to make sure that it's exactly the same on the other side, right? It's exactly the same on both sides, right? And this is the technical way that we can set a system to validate that something is the same as we're moving it. Now, this would also be the same if we were just leaving it in place. This is talking about moving the files and then waiting some amount of time. That amount of time could be like 5 years. Let's say you knew the hash of something and then you threw it off on tape. It's some old LTO4 tapes that are gone. And then you bring those tapes back 5 years later because you're getting rid of your LTO8 tape or your LTO4 tape system. So you got to pull all the data off those tapes. And then you check the integrity. So I tell you guys all the time, it doesn't matter if something was purposely damaged or accidentally damaged by the passage of time and entropy. It doesn't matter why you lost bits. You still lost data. Right? It's still a security incident as far as that goes. So technically what we do is we use hashing for that. Hashes take any length input and give a fixed length, fixed width output, right? So a SHA-256 sum is always going to be however many characters that is, and a MD5 sum is always going to be however many characters that is, all the time. All the time. All right? So come down here, and automation can check for change as well, so we can do that same thing inside of Ansible. Like this was Ansible and me just pushing a file and seeing that it did both a SHA-256 and an MD5 sum to make sure that the system right here is the same. The file is the same on either system as we push it. Okay. So we come down here, we get to tools. There's configuration management tools. So configuration management activities, version control, infrastructure as code. These are all these kind of buzzwords that you guys hear a lot in the industry. These are also on literally every job application if you want to be in IT. They want you to know version control. Well, version control is Git, right? Typically. Infrastructure as code. You're talking Terraform. Nowadays it's that Tofu, Open Tofu or whatever, which I can't imagine that's going to be around too much longer, but Open Tofu still deserves a mention. You can do Ansible, Bodo 3. Bodo 3 is the Python library for interfacing with AWS. I imagine there's some other ones for Google as well. But automation and orchestration, this is important to know. Like automation is your tools like Ansible and Bash and Python. But automation doesn't do anything automatically. Orchestration is what does things automatically and on a timetable. Your automation tools, your Ansible and your other tools, they just sit there inert in the environment. They don't really do anything, right? So anyways, Puppet Chef and Ansible for infrastructure automation. These are things that will help you to keep configuration drift from happening. And again, we can check things and alert, or we can actually catastrophically stop things from changing, all right? Docker, Kubernetes, this is container orchestration, but guys, really only Kubernetes at the end of the day. Only Kubernetes is your container orchestration, right? Docker is just Docker being Docker. Docker is a lot like I was just talking about with Ansible. It's not really doing anything. It's a tool that lays there inert until you're like poking it with a stick and telling Docker to do something. Kubernetes is your orchestrator. Kubernetes has the software-defined networking, and it has the putting pods in the right place and automatically connecting back to PVCs and those kind of things. Whatever. And then Terraform is typically known as infrastructure for code, but I've done a lot of infrastructure with infrastructure as code with Python, and you can also do Python. What was I saying? Terraform, Python with Bodo 3, and then Ansible. But there's another tool. You guys are always telling me about this other tool that does infrastructure as code, but I can't remember exactly what it is. 0 Day, thanks for the follow. Hopefully this stuff's useful to you guys. I am recording Unit 8 right now, so I'm minimizing anything that I respond to, but you guys are welcome to hang out and kind of go through it with us, and then I'm going to do the labs here in a second. So, all right, here's a system deployment process that kind of sums up a lot of the things I was just talking about. Someone requests a server. Somewhere, something on some desktop or on some wall, you can hit a button and build a server. That comes in as an API call to some type of process, right? That API call can also be made. Terraform is really just using providers to make API calls against things, right? So Terraform may have a VMware provider that connects and does VMware stuff. Some engineer may be manually building, right? They can copy a golden image and clone it over to a new VM, so they could be doing that manually, or an Ansible playbook can do it. We used to do this out of Tower, so and then Ansible can also be used for some of these other components as well. But someone requests a server, whatever it is, some process. And by the way, there's one that we have, I didn't mention it here, but we always had, if you guys ever see me talk about the, what's the name of that model? The failure modes and effects, FMEA, failure modes and effects analysis. If you guys ever see me do that talk on it, I actually use this example as where my failure modes and effects analysis comes from. This is my example. People could push a button somewhere. And what we did to fix things and to solve problems was we had our own process that would build servers every morning. It would build servers of one of every type in our environment. So it was RHEL 7, RHEL 8 back then. It was like Server 2016 or whatever for Windows and some other stuff. And it would just build all of these things, right? So anyways, the server builds start. Maybe a container stood up. If you're doing something inside a container, that's going to be a little more rare. Maybe a golden image is cloned to a new virtual machine. That's much more common. vRealize Orchestrator can do that. Maybe a physical machine is allocated. That's much more rare. Like you would have to have just a physical machine sitting there to apply an image to, but I have seen that before. That is possible to do that kind of stuff. All right. So then you come down here. There's two things to really understand here. You can have pre-baked elements that are already built into the image, and you want those things to already be there. So something you don't want as a security engineer is to pull up an old version of RHEL 8 or RHEL 9 right now, and it is still back from the original RHEL 9.0 disk, the RHEL 9 disk that you got when you downloaded RHEL for your company 5 years ago. Because what would happen, as soon as that server came up, you would have to patch that thing for like 45 minutes. Well, that's a waste. That's a waste of time, first off. But that's a waste in so many ways. But it also breaks one security posture thing that we always adhere to, which is never reintroduce solved vulnerabilities to the environment. So I have a lab. I'm going to pull the lab up, but we're not going to do it right now. I have a lab that is in Killer Coda that shows you guys that process, but it really just kind of makes you pretend to do the process inside of Linux. So hold on. I'm going to give you guys this. We're not going to do this lab. We didn't do it last night either, but I showed it to the guys last night, and I said, hey, look, this is how we, hold on, update, where's it at? So the idea is that you've patched some things in the live environment, and now you've got to go back and you've got to patch things, guys, you've got to patch things for a previous environment, or make sure, Pulumi, that's exactly what it is. Thank you for that over on the YouTube side. Pulumi is the one. Pulumi is a infrastructure as code type SDK, and I've seen that. I've played with that a little bit. I haven't done any deployments with that, but I have played with that a little bit, and Pulumi is the tool, yeah. And then it does a lot of infrastructure as code. That's for people that are coming from like the heavy coding and software side of things that need to stand up environments. Pulumi does all that, yeah. I've heard nothing but good things about that tool. And they've got a really slick website too, which is kind of nice. So I might need to include that in future versions of this. But I wanted you guys to see, this is the lab, and what it does is your server has a golden image that it uses to deploy new servers. There's a security requirement to not introduce old vulnerabilities into the environment when you deploy a new server. So you're doing this server right here, this golden image clone coming forward, and you're fixing that up. Now, you got to remember, in this lab, you're mocked up, you're pretending to do it, but your task is to update the image to the newest software, maybe remove some old ones that have vulnerabilities, and then go, right? So I just want you guys to make sure you're tracking that, okay? So there's two things that we kind of do with servers as we're building them. We either have pre-baked elements into them. One thing that we always pre-bake are all those patches like that. We will update a golden image with packages and that kind of stuff. But another one, sometimes, if I have a couple different data centers and a couple of different LDAPs, I may have a golden image in each of those. And LDAP is your lightweight directory authentication protocol, right? So that connects back to like Active Directory, or it does what we call establishes a trust. And sometimes we will do LDAP configs with a tool called SSSD, and I couldn't tell you what SSSD stands for right off, but it is the System Services Security Daemon or something, right? But it goes and it configures your system to realms, and it joins realms and whatever. Point is, that should probably be baked up because that's not going to change that much. Your STIGs, all of your security posture of the organization is pre-baked in. We don't need to be changing that once the system comes up. That should be built in. But there are things that have to come up later. So personalization, or in AWS, they call this user space. I like to think of this as customization. These are things on a server that by server environment or by server or environment basis, they're gonna change. So if you're a web server, an app server, or a database server, you have different paths that you're going to go down. It wouldn't make any sense for me to bake a web server, a database server, and a app server back here, and then turn on only the one I want. That would be, well, one, that would be a security violation in all kinds of ways because you'd have way too many open things, way too much software. But we're only going to apply what we need to for precision and accuracy, and then also for the system to work well. All right. So these are kind of the things that you need to know. These are sunk costs in time, and these are so these are already, you've already built them. These you pay for as the system comes up. And we're not doing security in AWS right now, but I do want to tell you, if you're using AWS and you're doing like what we call, you're doing load balancers and you're standing up new servers, if the server stands up and it takes 15 minutes for it to do all of its user space stuff, Well, what's going to happen is the server is not going to come ready enough, and the load balancer typically is going to kill it. There's like a 10-minute timeout by default. So you want to bake in as much as you can up in those. In that case, we call it an AMI, an Amazon Machine Image. But that could also be something that you would pull right here. It doesn't really matter the technology, guys. I always tell you, don't be married to the technology. Understand what we're doing, right? So anyways, we come down here, and I spelled typically wrong. Fucking, it's because it didn't spell check me. Final checkout occurs before we hand it over to users. But this process right here, if a human were to do it, I mean, how long do you think a human would take to go through and make sure all this stuff was right and go through and read the pages and pages of PDFs and build books? Weeks, maybe a couple weeks. And old server build processes did take weeks. But in a modern era where we need to run things and build, I need this building in under 5 minutes, especially if I'm trying to handle load for web servers. Web servers have to stand up very fast. In fact, I want my web servers up in under a minute. But anyways, my point is these build processes, we try to get them automated so that a system can do it under 5 minutes, right? So this is why configuration management is so important then, because I need to have these changes that are happening live on a system rolled back in so that they don't reintroduce problems later. Like, so back here, we were talking about, you know, you're doing security fixes and you're patching all this stuff, but then I come here and the next 5 servers I build are all deployed to an old golden image. That's terrible. You need to update your golden images as soon as your dev environments are good and it's rolling forward. Those golden images need to be patched as the rest of the environment's patched, right? So there's all these things to think about. So real quick, we're going to go to the review, and then guys, we're going to go back and we're going to look at the, we're going to actually do the labs. All right. So what's the life cycle of a system? We only talked about really the build part of the life cycle. On the other side of the life cycle, we do have decommissioning and those kind of things that we tend to do, and we'll leave a system, you know, back for like 3 weeks so that if we do need to access data off of it, we can. I like to build systems where we have our data all set to go onto network shares somewhere, but that's not always possible, especially in older environments. What is configuration drift? Anytime the system deviates from what you originally built, it is configuration drift. And you guys might not believe me, but you'll believe me after you do operations for a while. If you build 10 servers and you push them off and you were to check them a week later, I promise you they're all different in different ways. They can't be the same. It's not possible. There's too many other things happening. There's the load balancers connect to them differently. They have different. One of them's got log issues because it's the number one in the as you enumerate it through as you count through it. So it's the one that gets the most load connections. So its logs fill up. These kind of things are real problems that we don't find out from our testing and other things. We only find them out in the real world. So configuration drift. Then we go fix it. We fix it across all the systems, we note it, and then we make sure that it's baked into our builds later. All right, how do we deal with configuration drift? We got operational practices, we got to train our users, and then we can train our systems, right? Like, I always joke around with security, there's misconfigured systems and misconfigured users. Those are the only two things that, it's simple when you think of it like that, but those are the two things. You got misconfigured users and misconfigured systems. So operational practices are getting your users and sometimes your team and yourself to do these things correctly. Don't just one-off things and go around like you're shooting off in the air as the wild, wild west, right? Then we've got our technical practices. These are the things that we can do, like hashing and other stuff, to just one-off and check things as they move. System built-in tools like AID. We're going to do that here in the lab. AID is the Advanced Intrusion Detection Environment, right, like that. And it'll keep track of kind of like tripwires all over your little environment. Anybody here ever see that movie? What was that movie where she breaks his legs because she doesn't like what he's doing with the books? It's an old Stephen King. And it's Misery? Is it Misery? I think. Yeah. I spelled. Yeah, I looked at that last night and I didn't fix it like I should have. But anyways, Misery, right? The movie's Misery, and she puts her hair across things so that when he goes, like the hair breaks. That's what this is like. It's the same kind of neuroticism that would cause somebody to track where you've been in a house. Yeah, Kathy Bates, that's exactly right. Yeah. And then fixing drift, we can either just check things and watch and go, that's really terrible what's happening to that system, or we can do something about it. Both of them have implications, right? Everything always has. All right, so questions, if you have questions, reach out to me. And then we're going to go and we're going to look at the lab. And here's the actual worksheet. So if you're doing the course with us, here's what we're doing in the course. So ProLUG Unit 8 worksheet. We went over this last night in the group. And I said, read about configuration management here. You go to the Wikipedia page on configuration management. And I said, what overlaps of terms and concepts do you see from this week's meeting? Now, they're talking about configuration management, so they're way outside of just IT. They're doing all kinds of other things. But a lot of the technology not even technology, terminology and concepts are the same. So where are they similar? Where do they differ, right? Then I say, what are some of the standards and guidelines organizations involved with configuration management? When you get down to the bottom, you see ISO, you see IEEE, and you go, oh, these engineering groups are involved with change management. Who would have thought? If you want to be an engineer, you have to track when the engine changes, right? And the engine is just the cycle of whatever it is that you work through and whatever you work on, right? Okay, so we come down here. Do you recognize them from other activities? Unit 8 has discussions. Then discussion post 2 is review the SRE guide for treating configurations as code. Now, they're specifically talking about software configurations, but the line is so blurred nowadays, guys. It's so blurred on this. So then we come down here to practical advice, and at the bottom of this section, when you read this, they've got some practical advice, and they give you some security threats that can happen within your configuration. So I think that's excellent. There's some terminology for you to look up. There's some notes and other stuff like that. Now, the guys have already put this into the book. So let me pull the book up for you guys. If you guys were like, well, hey, where do I find all this? Here's the book. The guys have already put it in there for you. So you guys could follow along if you needed. So that's on both sides there. And then the course syllabus again for this week was configuration drift and remediation. Good. All right. Then there's some reflection questions about how does this idea of control play into configuration management. In security, we have different types of controls, right? We have technical controls, we have physical controls, we have administrative controls, which have been broken down into, I think, managerial and operational nowadays, but there's different types of controls you're going to run into. And how does that play into configuration management? And how does that tie configuration management back into being something that you're going to do as an engineer? Okay, so let's get rid of that. In the lab, so here's the lab for this week. It says make sure you have putty or some other connection tool. Actually, you know what? I'm going to move this out and I'm going to move it over because for the lab this week, we need some of our components. So the first thing is make sure you have your stuff. If you have not looked at this tool lately, this is a tool that we use often here, which is the STIG viewer. And for the STIG viewer, real quick, the lab focuses on drift tracking and remediation. So we come in here and we look for change management. We are inside of the STIGs for RHEL Enterprise Linux 9. So Red Hat Enterprise Linux 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That answers one of the questions. How many STIGs do you see? And then they keep talking about this robust change management process and part of a robust change management process. And it kind of feels like, even though STIGs are supposed to be discrete things, it seems like all of these are assigning you additional homework in your company of whatever you're deploying of having these other things. So the RHEL 9 system commands must be owned by root because only people that have permissions should be able to do DNF and install things on your system. Only a root administrator should be able to change where your repos are going. If anybody else can do that, if anybody else even has sudo to that, there's a problem in your organization. There's a major problem from a security standpoint. So anyways, we come down here and we keep going. Check your STIG viewer and go to RHEL 9 STIGs, and then we keep going. All right, so monitoring configuration drift with AID. We're going to go into over here on this lab here, and I just have you guys go to a generic lab inside of Killer Coda. So we're going to go right here. If anybody wants to follow along with the lab, you can. All right. And we're going to continue with this. Hold on. All right. So we're going to go. This is a normal sandbox. I haven't turned this into its own lab because I don't really think this one needs its own lab. But I'll probably do that later and then update this. But first thing we're going to do is apt-y install AID. We need AID on the system before we can even talk about any of the other things. You can just hit OK on these. Just let it do whatever it wants. And it's just going to go ahead and tell you that you know, there's nothing going on over here. So I say, what is being put in the path of etc aid aid.conf.d by default? So you're going to see a bunch of things getting installed here. And then you're looking at them and going, well, hold on, that's interesting. It looks like there's an Apache, and there was a run and a cron, and a, it looked like a DPKG. It looked just a bunch of things scrolling by as fast as we can, right? There's a bunch of things rolling by here on the screen. So we've got, let it finish up here. Some of the ones that are kind of interesting here is like SSH, NFS. We want to track those configuration changes because if people can change NFS configurations, they can share ports out on our system. They can share out file systems and start to read them from other systems. If they can turn on or change SSH in some way, they can open ports and do reverse shells back and stuff, right? We don't want them to be able to do that. So if we have that locked down, we're making sure that it's locked and staying the way that it is, right? So we're going to scroll down over here, and we're going to do an aid-v. And aid-v is going to tell us how aid is going to work on our system. What is aid ready, as it were, to kind of do? So we come right here. Where's our aid-v at? Right here. Tells us the version of aid. Tells us that it's being POSIX A6. So POSIX ACLs are all of your normal ACLs when you do like an ls-l on a box. Then it's got SE Linux and X attributes, so additional attributes to systems, which you can use with LSATTR and CHATTR, right? You can do all that. We're going to come down here, and there's a bunch of compiled in attributions that they can have. They can go look at file systems and SE Linux, which is another additional level of labeling that we looked at in, I think, the first week of this, maybe the second week of the course. We did SE Linux. And then here's all the hash attributes that it can check. I'm really only familiar with these ones. These other ones, I never really messed with them. But there's a whole bunch of other ones that are available that you can then use for hash sums if you want whatever level of additional things. So here's some default compound groups that are already there. And actually, there's a setting that you need to change for STIGs with aid on this. So if I were to go right here, guys, if we go over here, where do our thing go? Let's pull up our STIG viewer. And one of them here is if I went to filter and we got rid of this one and we said aid, what are the things I have to configure for aid? Well, I need to make sure that aid is initialized. I have to make sure there's a database for aid. And then I need to also make sure that these are all the values that are set right here at the bottom of etc-aid.conf. So we can go put those values in. If we wanted to configure this system for these two aid checklists, to be able to say that we had configured, no, this is a Red Hat box and this is an Ubuntu box. So it's not exactly the same, but the value's the same of what they're trying to do. So, all right, so we're going to come down here. I say you can go check etc cron.d. Sorry, cron.daily. Cron.daily on a normal Linux box operates at 3:14 a.m. Why 3:14 a.m.? Who knows? It's configurable. You can go find it if you want. Go look up how to change when etccron.daily runs. I think it's in etccron something, but you can change how it works. In here, there is a daily aid check. And this daily aid check right here, guys, this thing that's running, or could be run every morning, is going to check some things. And I ask you in the lab to check, what is this test doing right here? What does that mean? What does this mean right here? So figure that out if you don't know. Come down here, what is this doing? This is executing or testing something around this. And then it's going and looking at this command capsh and doing something. So what does that do every morning at 3:14 a.m. is the question, right? That's what the lab asks you to think about, right? And then we got to get to the part that's going to take some time. We're going to go and we're going to time the creation of our first database. So if we go to aid.conf and we run this, this is going to take about 5 minutes. So let's let this run real quick here, and then we're going to go. All right. How long did it take? How much wall clock time? It's going to take about 5 minutes for that to work, and then we're going to go. Yeah, then we're going to go. All right. Trying to not cause a problem here, but there's too much distractions going on. So we can deal with that another time, another way if we want. But all right, this is going to take about 5 minutes to run, guys. When it's done, it's going to tell us our wall clock versus our system user time, right? And our system user time, why might we want to know this? Because we need to know when we first build this database what that's going to kind of look like, right? What's that's kind of, hold on guys, I got to go fix something else too. Hold on. Need a second here. Is trying to find something so I can delete something real quick. Oh yeah, I get rid of that. Archive. 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 All right. Getting rid of that. All right, sorry guys. I had to remove some stuff when people want to bring up old stuff. I gotta go clean stuff up. So, all right, this is gonna take a few minutes, and we're going to. Okay, how long did this take? And then when we get to the bottom, we're gonna see a bunch of output. It's gonna go and send a bunch of these tripwires. I know it's called AID now, but originally a lot of us thought of it as tripwire. It's going to go tripwire all over through the environment, and mine took 5 minutes and 8 seconds, and then I think 5 minutes and 16 seconds. So it takes a little bit of time in your system to run. And then we're going to set up the database. Now the database was set to aid.db.new, and we got to go put it in the right location. So the original database is never put over the top. The reason that's done like that, the reason that's created like that, is because you will never have right here. The reason this is set like it is right here is you would never want to overwrite the actual database. If the database was there and somebody were to accidentally initialize the database again, you wouldn't want it to be set there. Okay, you wouldn't want it to go over the top of the database because the database is there for the values that it has. Now, there's something I really need to make sure you guys know about this, and this is very important, where if the system right here is damn distractions. If you're running a stateless node, right? So a system comes up and boots stateless every time, AID has no value because AID can't track what's there if you're going to be coming up in a stateless node every time. Okay? If you're stateless mode, you're not going to be able to do that. So, all right. So this is almost done. And when it's done right here, we're going to see the information coming out of there. Yeah. It's something, Runamucker. It's definitely something. All right, this took 4 minutes and 6 seconds, so maybe their environment's not as hot as it was before. We're going to paste this over here, and we're going to come over here, and then we're going to delete, or we're going to put that in place. Now, we're going to go make some files. We're just going to make a directory first. I can type these up. I don't need to copy these. We're going to just make that. We're going to touch root ProLUG test 1 and test 2, right? So we're just going to make these. And then when that's all done, we're going to run an aid conf check, and we're just going to see if we can see that something was changed in one of the directories that we were tracking. By the way, right here, it's 128,207 things that this is checking. The database entries are the files, where they're at, the state that they're in as far as all the ACLs and all of the SE Linux states and all that kind of stuff. So it's tracking all of these things, and it put it here in varlib aid.db.new, and then we went and we put it in varlib aid.db. So it's the official one that's going to be used in the system. So now we're going to go check, did something change in the environment? Oh, you know what? Just for fun, let's go change another one just for fun. Let's vi etc cron tab, and let's go to the bottom of this and say, this is a test, right? Does it find cron tab changes? Let's go find etc pass wd. So we're going to add it. Well, let's do something else. We'll just add a user add -m some user, right? And we'll make that user on the system. And then we'll go through this little thing here where we're going to check what is it seeing as different in this environment. I didn't make you guys change a whole lot of stuff, but I'm making it change this right now. Look, oh, this one was 127,866. Look, I want to show you guys something real quick. This is very important. Last night when I did this on one of these boxes these are cloned systems that come up every time the exact same way inside of a tool called KubeVirt. That's what they run inside of Killer Coda, an open source tool called KubeVirt. Look at this. Last night, 127,866. Today, 128,207. And you say, Scott, what are you trying to prove here? All I'm telling you is when two servers go off from the exact same baseline, these were exactly the same servers about 30 minutes before these things were both taken, and there is 400 differences between this one and that one in aid. Because I mean, look, if they were the same, if they had the same events happen to them, they would be the same number right there, but they're not. And you guys didn't see me do anything else except install aid and run some basic commands. It's tremendously interesting how many things change in a system. In fact, it's so much that I would say it's unquantifiable. And you say, yeah, but couldn't you log everything? You'd probably crush most systems under the weight of their own logging if you were trying to do that, because there's so many things happening, right? So anyways, this is going to run. But yeah, when I did it the other night, you would just see the entries added for root, ProLUG, and those kind of things. But now we should also see changed entries too. These were things that had just changed by nature of changing. But when we see it over here, we should see cron tab changing. We should see Etsy pass WD and Etsy shadow. Well, there should be a shadow entry even though it's empty. We won't see what they are, but we'll see the changes over here. And all of these little codes mean something, but we don't really need to memorize those unless that's where you want to take your career, right? That kind of stuff. All right, so we'll let this run. We'll let this finish. All of these labs have questions in them that I want you to be pondering as you're doing the lab, right? I'm just talking through it. But for you guys, there's a bunch of questions about what is this doing? What is it attempting? What is it calling? And they're all things that are valuable to you if you want to set up systems engineering. I'm going to tell you right now, if you go looking for like a Linux admin job, almost all of them are going to have some type of configuration management, CMDB, configuration management, Git, or any of these things where they want you to understand that the things that are being changed have to be tracked. That's all they're trying to do. So there you go. All right. So get down here, and we'll be getting to using Ansible to fix drift here in a second. Also, all right. So that's going to run. This will take, I don't remember exactly how long this took when I did it. I want to say it was around 5 minutes again. It might say it up at the top here. They do give the start timestamp, but I didn't capture the whole thing. So we'll see at the end, and then we'll just go through and see if we can see the things that we know that we changed. And then we can set aid when things change, so when those things change, to alert in certain ways. You can have it alert emails, you can have it alert create files, run scripts. You can do all kinds of things with aid. By the way, aid is only running at 3.14 every morning, but you could have aid run more aggressively on some of your systems if you wanted to. I would say that there's maybe a better way to do that. Maybe have aid just checking things, and then maybe just watching. If you wanted to really do that, watch the logs coming off of a system, and make sure that the logs that are coming off of a system are based on the user login and those kind of things. So then we could track, like when an admin comes in or somebody with sudo permissions, and then we could go and trigger, and then it would make sense who had made the changes. We would at least have it narrowed down. A lot of people we always track in an organization all the time sudo is called. And then we force all users to not be root. You have to come in as a normal user, and then we can see every time you call sudo. We just know what's going on with your users. So it's very kind of important. Okay, so this should almost be done here. And then our next one, we're going to go to this lab. So I will link this lab for you guys that want it. Here's the next lab we're going to go into. And this next lab, we're also going to play with it kind of off to the side a little bit, and we're going to do the lab, and then we're going to check some things and actually affect some change back in the organization. We're going to do kind of that thing that I was talking about. We're just going to lay the hammer down. We're just going to force the environment back to what it was, and then we're going to test some things as we do it. So let's let this other thing finish. We're gleaning whatever good information we can out of this tool. Looks like Aid read the database properly. That's good, and now it's going and looking for all the changes. It's oh, that's that up there. We're still down here now. We're doing all of those things. It just hasn't presented that to us yet. So. Yeah. Take a second to come back up. So let that run. If you guys have any questions about the course or any of the things that we're doing, just ask them down in the Discord. All this stuff's free. All you got to do is go in there and just start doing it, right? It's a lot of work, though. It's like 10 hours a week at least, I would say, for this stuff. In fact, the last week's stuff, I think the labs went a little long for everybody, but it's valuable to get your hands on this if you've never touched this stuff. See where this works and see where this breaks, right? Because maybe this breaks for you, and then you got to go troubleshoot and figure it out a little bit, right? So, all right, let's get down to, all right, so that's all done. It took 6 minutes and 25 seconds, so it was a little bit longer. And we come up here a little bit, and we should see, hopefully we can get all the way to the top here. We made a lot of changes, so that makes sense that we made more changes this time. But if we can manage to get to the top here, look at all these changed entries for all of those. Yeah, that makes sense. We made a user, and some user was made. Yep. But then also we see the root ProLUG stuff. There we go. And then we see these added entries of home user. We see the files that home some user was populated with, which are all the .bashrc files that come out of all of these come out of Etsy scale directory, right? And then here's all the changed entries, and then here's the detailed information about the changes. But if I just want a summary, these would be the summary of things that had changed in my system. That's kind of useful right there, right? That could be a useful little report maybe to see every morning. If and by the way, you would only send the report if something changed. If nothing changed in your environment, besides maybe you only track for like the word home, and then you only send it if home happens. There's all kinds of ways that you could probably do this. So, all right. Anyways, so we get down here to the bottom, and we get to that next lab. So I'm going to pull up that next lab here, just right here. All right. And this is going to be Ansible web server deploy. So we're just going to follow along with the playbook real quick. We're not focused so much on what this playbook is doing. There's a whole lab on this. You can do the lab if you want. And this lab points back to another lab where you go and do it by hand in Linux if you want. So if you've never deployed a web server, you'd go here. If you have deployed a web server and want to do it with Ansible, you'd do it here. So we'll cat our Etsy hosts, or our root host file rather. Cat that file out. Boom. We see that we have 2 servers, and then also a web server only, which is right here. Then that's the break at the end of the file. We could, if we wanted to, root hosts. Now it looks like that. That looks a little nicer. But anyways, we can go and we can look at what's there already. There's some files that have been created and stuff for you. And then down here, if you read through it, that's fine. But at the bottom, you can just run it. So I'm just going to copy that in place and run it. And we're going to deploy a web server with 3 different ports open for 3 different web pages in our environment, right? 8080, 8081, and 8082, right? 8081, yeah, 8080, 8081, and 8082. Those are our environment things. Here's all the things that are happening. We have to restart Apache, and then we go look, and we see all of our web stuff up. All right. So all of our web pages, if you curl 8080, you see dev, you see 8081 is test, and then 8082 is QA. Good. We come over here. You've been extremely successful. The teams want to to ability to deploy or turn off only certain parts. So they find out, actually we have it over here, we'll read it here in a second, but let's copy over this individual web environment and let's remove, we can read it and see what it's going to do. And then let's remove the test on port 8081. So we're going to remove that environment from our system. So real quick, if we wanted to, we could go back here and rerun this command, and we'll see the first one and the bottom one, but not the middle one. So the first one worked, this one failed, this one worked, because somebody ripped out the middle. So I say over here, one of your dev teams figured out that they could modify the test and QA environments because a previous engineer left them in the sudoers file. So they've been in there mucking stuff around, and now this is the state you get in. Your system's busted. You can address this separately with a security team, sure, but now you need to get those environments back working. Run your original deployment again and see if it fixes it. So we're going to just run this original deployment over the top of that. Right, we're just going to paste it. Let's see if this will deploy and fix that one thing that's busted. Yep, just laid it over the top. And let's go back. Let's hit this, and everything's fixed. And then they find out that they can delete. You know, they got rid of this one, and then maybe they found out that they could do, like they could do QA on 8082 as well. But the environment needs to be up for some other teams that come in at night and work on the environment. If I run this right now, it's going to be busted. So only one of them is going to be working, right? And now, while I'm doing this manually by hand right here, I hope it's clear that if I were doing this, if I had a program, let's say I had an orchestrator like Ansible Automation Platform that just called this every 5 minutes against the server, this would hit that environment. Look, it's going to hit that environment, and it's just going to overlay it back to the exact same way it was. It's like bulldozing it over and starting over again. And then we're going to be back to a fixed environment that works again every time. So this is kind of that idea that we just clobber over the top of whatever they changed. Then I said, did this force the system back into a working configuration? It sure did. Oh yeah, it forced it. If it worked, would it always work? Could they put this in a state that that wouldn't work on? The answer to that's definitely yes. This thing doesn't have all the checks. This is just a basic playbook to overlay your base configs. So could they break it? Yes. Yeah. Could you put a shunt in a door so I can't close the door anymore, even on like a nuclear reactor? Yeah, you could. You could put something in a door works the way a door works. If I put a shunt in there, if they were to do certain things to this, they could break this. Yes. They could change the pathing. They could do all kinds of stuff that would break this. But that being said, that would take a lot of extra effort and would, be outside of change management stuff at that point. That would now be firing people type stuff. Anyways, what's your test? Curl all those. I said, could this cause potential problems in the environment? Yeah, if they got their system the way that they liked and added a bunch of tools and changed port numbers and stuff, and then I went back here and did this, it would be catastrophic to whatever they were doing, as it should be. However, you got to remember, if you're running an automation that does this, just know that one day you're going to get a call. It's going to go all the way up to the bridge, and they're going to go, no, this needs to be running all weekend, and now you're going to have to fix it. Well, you're going to have to fix it, or you're going to have to leave your position, right? Those are going to be your two options, because it's very unlikely that your manager is going to be high enough up to be able to say, hey, no, you know what? No, fuck that. We're not changing that back for this team when they've broken all these security things. No, let's get security involved. Most of your managers are just going to be like, let's fix it for them. We'll have that fight next week. And you're like, I'm already updating my resume because you don't got my back, right? Like, anyway, so that's the point. And then there's another lab. There's some challenges. You don't have to finish this for the actual lab. And yeah, the right 3 letters thing, yeah. CSV and this other one where you could do some stuff where you could probably add to this a little bit. So I have some other stuff like that you could do. Okay. So with all that, the lab itself is done. And then we are 1 week away from finishing the content of this. Now we just have Unit 9, which is going to be all certificate and key stuff. If you've never done testing keys to make sure that a public and a private key actually match, the name isn't the only indicator. There's cryptography involved, right? We have tools that we can do to check that 2 keys are significant to each other. We can also test certificates the same way, so we'll do that. And then we'll use certificates to control some of these communications that we've had. Everything we've done up until this point, all the monitoring and alerting and stuff, I didn't do any certificates yet because we just wanted to see it work. Now we're going to lock it down with certificates and start to adhere to what we call the zero trust principle. And the zero trust principle is huge. You're going to find a lot of people in the, like I like to call it the cult of Ansible for us that use Ansible, but you will also find the cult of zero trust. They'll be like, where's our zero trust at? Where's our zero trust at? No more conversation until we have our zero trust installed. And they're right in a lot of ways, because really things should only talk to things that they're supposed to. That's the way systems like this work. So, okay. Let's call it there then. I appreciate you guys all coming by. We will go ahead and I probably won't be on later tonight because I've got work to do, and I've got a family thing going on later on tonight. So I appreciate you guys all coming by, and I will talk to some of you guys later. Take care.